Welcome everybody. This is the first of a small series of tutorials dedicated to GC315 MF genset controller. The purpose of this video is to make it easier for you to interface and connect the controller. Generally speaking, for a genset controller we can divide the available connection in 7 categories: digital inputs, digital outputs, analog inputs, analog outputs, specialized digital input-outputs, generator measures and communication interfaces. In this tutorial, we are not going to cover the generator measure interface and the communication interfaces. Moreover, since GC315 doesn't have any analog outputs, we'll take into account the remaining 4 categories. But let's start our tour. GC315 has 8 configurable digital inputs. It is possible to add up to 4 more inputs, using analog input if not used for analog measurement. The 8 inputs are accessible by the A terminal of connector JN. By default, in order to activate an input, the input should be connected to ground, while it remains deactivated if disconnected. The 8 inputs have predefined functions. This can be easily checked by both G3 or through the controller display. Configuration can be carried out by means of the front panel, accessing the menu 1.7.2. In this menu, there are 3 sub-menus. The first is dedicated to the 8 digital inputs of connector JN. The second to the analog inputs, when configured to be used as digital input. The last menu is used to configure the system virtual input used for the configurable logic. More easily, the configuration can be made by the PC software board G3, accessing the tab I/O and selecting digital input and then controller. Here you can find the 8 inputs plus the analog inputs configured as digital ones, if any. Selecting an input, it is possible to change the related parameters. If the function selector parameter is set to 0 not used, no other parameters are shown. Otherwise, a list of 3 parameters will be accessible. The first parameter is the input function selector. If input is not used, set the function 0 not used. The next parameter allows to set up a time delay for the input. Beware, this value takes effect only for some functions, not for all. A list of digital input functions is available in paragraph 5.5.3 of the technical handbook of GC315. This list, in the column delay, shows the function affected by the time delay parameter. The third parameter allows to define a custom text message for the selected digital input function. Not all the digital functions are affected by this parameter. The same diff list has a column that shows the function affected by this parameter. A description explains also how this text is used by the controller. Remember that a maximum of 30 characters are actually used by the controller, even if both G3 allow to insert more. The default text of the parameter instructs the controller to use the predefined text message of the active language for the selected function. A checkbox in the configuring software allows to reverse the activation polarity of the input. GC315 has 8 configurable digital outputs. There are 3 different types of outputs. The reason is that some outputs are mainly dedicated to specific functions, although they are fully configurable. It is possible to select the output function among a list of 38 different ones. You can find a list of available digital output functions in the technical handbook of GC315 at 564 paragraph. Function 103 and/or logic is used for configurable logic. Configuration can be carried out directly on the controller by programming menu 1.7.3 or using board PRG3. For configuration, only one parameter is available. Four generic outputs are available through connector GE. These are static outputs sourcing positive voltage when activated. Maximum current is 500 mA for each channel. Two relay outputs, predefined for engine interface, are available by means of terminal JL1 and JL3. These outputs source positive voltage when active. They can source up to 3 A each. They are predefined for the starter motor and the fuel valve. The 6 terminals connector JI allow to access the two relay, mainly used to command mains and generator circuit breaker, contactor or changeover. Each relay has 3 terminals, common, normally closed and normally open. Thus they are free potential contacts and each can switch up to 10 A at 250 volt. Digital output configured for stable mains circuit breaker command using function 2004 is activated in order to open MCB. Thus, the normally closed contact of relay should be used in order to command the breaker. The advantage is that in case of controller power off, the MCB is automatically closed. In any case, you can reverse the operation by the checkbox to reverse functionality. As for specialized input-outputs, we can enumerate 4 inputs, 3 of which dedicated to the engine speed measurement. Magnetic pickup or, as alternative, double view, can be connected here for such task. Pickup can be connected by a single wire to JM5 or by 2 wires to JM5 and JM6. If using double view, connect it to JM7 and short JM5 to JM6. By means of menu 1.2, it is possible to configure pickup and double view. Set P110 with the gear teeth number for the pickup or P111 with the ratio of RPM and the double view signal frequency. If not used, leave P110 and P111 set to 0. They can't be both set to a value greater than 0 at the same time. The fourth input is dedicated to emergency stop push button, and it is shared with the positive battery connected to input JL2 and supplying the relay predefined for fuel and start command. If no voltage is present at this input, the emergency stop command arises. At the same time, the lack of power prevents the 2 relays from supplying the crank motor and the fuel valve, issuing a shutdown command. In this way, safety requirements can be easily met, simplifying the overall cabling and freeing one standard digital input terminal. controller has 5 analog inputs. 4 of them are configurable. The 5th has a fixed function. Anyway, the 4 configurable analog inputs have a predefined function for which they are optimized. These inputs are JM1 analog reference, JM2 fuel level, JM3 oil pressure, JM4 coolant temperature, and JL4 D+. As alternative, all of them, but JM1, can operate as a configurable digital input. Depending on the connection, steady or transitory voltage can develop across the engine and the controller ground. Usually, sensors are cabled only by one wire, and this voltage can influence the resistance measurement. It is not mandatory to use this input. In this case, a good ground wiring system or two-wire sensor cabling should be provided. If not used, JM1 must be connected to ground. If used, the engine sensors should be connected to these 3 inputs. They can be configured for standard video sensor or with a custom configuration curve. Later we are going to see how to use them. Resistors up to 2 kΩ can be measured. Depending on the input, the analog measure function can be changed selecting another one from an alternative list. If JL4 input is used for D+, its terminal also sources the citation current for the battery charger alternator. Besides this function, the plus input is used to detect the engine running and the belt brake. The 2 functions can be enabled independently. If not used for the plus, the input can be used for voltage measurement, selecting among a list of available dedicated and generic measures. Configuration of the analog inputs can be carried out by the programming menu 1741 and by board PRG3. Some features can be configured by the programming menu and require the configuration software. In board PRG3, if the input is configured as 0 not used, only the parameter for function configuration is shown. As soon as a function is assigned, other parameters will be shown. If the function assigned is 100 used as digital input, an additional parameter is shown. This parameter allows to insert a text message, but in this context, this parameter is reserved and does not take effect. If it is needed to add a text message, the parameter available configuring the digital input must be used. Selecting an analog function, a total of 8 parameters will be shown. The first is the function selection, and the second is the text message, that, in this case, could be used. The remaining 6 parameters allow to define a threshold with hysteresis that can be used to generate a warning, a deactivation or an alarm, or to change a dedicated status that can be managed by the configurable logic of the controller. Beware that the function you assign to these analog inputs could already have the standard protection threshold. You can find them in menu 3, and they are those to be used for standard purpose. You can use this threshold for additional protection, or to implement some logic based on measured values. Board PRG3 allows to carry out some advanced configuration. We have just seen that for each analog input, it is possible to define a threshold for the assigned measure functions. Actually, this threshold can be also configured by menu 1741 analog inputs. But assigning the right values to the two configuration parameters for the status could be a little tricky. Let's configure an analog input and use these thresholds. We are going to add a threshold to coolant temperature. This can be used in order to activate an output, might be for additional fan or cooling system. We are going to activate the output when temperature is above 85 degrees Celsius and deactivate it when below 80 degrees. After assigning the function 1110 coolant temperature VDO, we have now a group of 6 parameters for threshold settings, in addition to function selection and test assignment. Of these 6 parameters, the first sets the first threshold, and the second assigns a filtering time to this. The third parameter is used to configure the threshold functionality. We have to set the first threshold to 85 degrees Celsius and its delay to 50 seconds. Now it is time for the first configuration mask. As you can see, the first bit defines the threshold direction. If off, the signal has to become greater than the threshold, upward. If on, the signal has to fall below the reference, downward. In this case, we leave the bit off. The second bit defines whether to set or reset the internal status of the threshold. In this case, we have to set the status, and thus we have to set it. Other 3 bits define if a warning at the activation or alarm should be activated, while the following bits define conditions to apply to the anomaly. It is not mandatory to activate an alarm in order to use the threshold. The only internal status can be used directly to activate a digital output or an input function. In this case, we have not to set them. Usually, the first configuration table is used to set the internal status and, if required, to activate the anomaly. The remaining 3 parameters set the other threshold for the hysteresis. If the first group set the status, the second should reset it. If the first has an upward direction, the second should have a downward direction. If the status is not reset, the associated anomaly or output cannot be reset, unless to power off the controller. Then we set the second threshold to 80 degrees Celsius and its time to 50 seconds too. In the second mask, the first bit has to be set, since it is a downward threshold. The second one has to be left unset, since it has to reset the status. Now it is possible to assign the status to an output. Select the required output, the AND/OR function, add an element and select status of threshold on analog measures, and then coolant temperature. And we have added this new functionality to the genset. No compiler and program to develop. It is all simple configuration. When configuring an analog input, it is possible to select a measure or a sensor of generic type. In this case, the controller has not built in the transfer function. This has to be provided. This can be done by board PRG3. The program has some predefined curve that can easily loaded into the controller. However, it is possible that a different, not separate curve is required. By means of board PRG3, it is easy to fill a table in of up to 30 points, which define the curve. Let's see how this procedure works. The only limitation is that in the first column, the data have to be placed in ascending order. Curve can be stored for future use. GC315 has the possibility to show the fuel level liters beside the standard percentage value. There are two possibilities. The first is to show liters as an alternative to percentage. The second one is to show an additional liters measure alongside the percentage measure. In the first case, you have to simply select the function 1231 fuel level generic instead of the function 1220 or 1221 for the percentage. A curve converting resistance to liters must be defined. In the second case, the fuel level sensor must be configured as usual for percentage value. Then, use the first analog virtual input and assign the function 4094 engine fuel level liter. Once the curve relating to the percentage value to liter is compiled, the liter value is shown on the controller screen. It is possible to expand the number of available digital and analog inputs and outputs by means of external modules. Regarding the digital inputs and outputs, up to 2 expansion modules can be connected for a total of 32 inputs and, if included, 32 outputs. The expansion modules must be connected on CAN bus ECU interface. Adding an expansion module can be easily accomplished by board PRG3 or by the programming menu of the controller, using menu 171. Set P141 to 1 or 2, depending on the number of added modules. Analog inputs can be expanded by external module. Up to 2 temperature modules, D-green for PT100 or D10 for thermocouple, can be added for a total of 6 temperature channels. An additional analog voltage current input module can be added too, for a total of 4 channels. At the beginning of this tutorial, we said that GC315 would not have analog outputs, and that the subject would not have to be covered. Actually, it is possible to connect an external analog output module that supports 4 analog channels for auxiliary functions. In order to enable output module, set the value 1 in parameter 144. Through this video, we have seen how to connect and configure the digital and analog inputs of GC315. Moreover, we have seen some of its advanced configuration and how to connect expansion units. In the next tutorial, dedicated to GC315, we'll see some other features of this exciting controller. See you soon, and don't forget to subscribe our YouTube channel.